Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss hierarchical clustering. So that I already given a brief idea about this agglomerative and divisive. We are going to discuss in detail in this lecture. So this lecture will cover mainly the agglomerative versus a divisive hierarchical clustering, and also another important thing is the distance measures used in algorithmic methods. So while partitioning methods meet the basic clustering requirement of organizing objects, a set of objects into a number of exclusive groups. In some situations, we may want to partition our data into groups at different levels, such as hierarchies. The hierarchy clustering method works by grouping data objects into hierarchy or a tree of clusters. So it is mainly useful for the data summarization and visualization. So we can easily summarize or characterize the data that are organized into the hierarchy. Agglomerative methods start with the individual objects as a clusters, which are iteratively merged to form the large clusters. Conversely, that is a divisive method. Initially, let all the given objects from one cluster, which they then iteratively split into the smaller clusters. The hierarchical clustering methods can encounter difficulties regarding the selection of a merge or the split point. As we discussed in the previous lecture, this is one of the disadvantages with the hierarchical clustering, that is a selection of merge or the split point. Once it is done, it would not be undone. It will neither undo what was done previously nor perform the object swapping between the clusters. So thus merge or the split decisions, if not well chosen, may lead to the low quality clusters. As I said, it would not be redone. So moreover, the methods do not scale well because each decision of merge or the split needs to examine and evaluate the many objects or the clusters. A promising direction for improving the clustering quality of hierarchical clustering methods is to integrate hierarchical clustering with the other clustering techniques that results in a multiple phase or the multi-phase clustering. There are several orthogonal ways that is to categorize the hierarchical clustering methods, that is categorized into the algorithmic methods, probabilistic methods, and Bayesian methods. Agglomerative, divisive, and multi-phase methods are algorithmic, meaning they consider data objects as deterministic and compute the clusters according to the deterministic distance between the objects. The probabilistic methods use the probabilistic models to capture the clusters and measure the quality of cluster by the fitness of the model. Hierarchical clustering method can either be agglomerative or divisive. That is depends on whether the hierarchical decomposition is formed, that is a bottom up, or that is merging or splitting, that is a top down fashion. In either agglomerative or a divisive hierarchical clustering, a user can specify desired number of clusters as a termination condition. So the termination condition, once we meet the number of clusters, like based on the number of clusters, the process of this constructing this hierarchical clustering would be terminated. So let us consider one simple example to understand how this agglomerative and divisive hierarchical clustering would work. So agglomerative is merging, that you can see here. There are it, as I said, initially considers each object as a one cluster. There are like 5 objects, so each object is one cluster initially, that is at the step 0. And next, the similar objects, so here merging would be done, that is to combine the objects from the cluster A and B, and these 2 objects, that is happens in the second step. Next, the third step, the 2 other the clusters would be merged and to make the another cluster. And next we'll find out the similarity between the this cluster and also the another cluster. So then it will be merged to form the new cluster, and then the similarity based on these two clusters and the new cluster will be formed, that is merging these two clusters. So that each and every step the clusters, the individual clusters or the clusters would be merged to form the new cluster. That is a bottom up approach. Whereas a divisive approach, so the first, because it would consider the entire all objects as one single cluster, so that is at step 0 all the objects are belongs to the one single cluster. And then the second and next subsequent iterations, it would divides based on the dissimilarity among the objects within the clusters, so that the same process that it will divide splits the cluster into the different clusters, so step by step. And finally, so this the stopping criteria, let us say, like suppose, and this is the number of clusters, like agglomerative clustering, the number of clusters here 1. Like suppose if the number of clusters is 2, like, so now it would, now these are the 2 clusters. Okay, so like, and similarly in the divisive method also, if you wanted 2 clusters, 3 clusters, or the 5 clusters. So if the stopping criteria, the number of clusters specified is 5, then it has to complete all the steps. So then we will be having a 5 clusters. So that is the way the construction, the stopping criteria works. The challenge with the divisive method is how to partition large cluster into the several smaller ones. So next, another important thing is that is because in every clustering approach we use a distance, we find the distance, based on that distance we observe the similarity or dissimilarities. So there are 4 distance measures used, like a minimum distance, maximum distance, the mean distance, and the average distance. And here the Ci and Cj are the clusters, and these are the data points, like a P and P dash. P is a data point of the cluster Ci, and P dash is the data point of the cluster Cj. So when an algorithm uses the minimum distance, that is from between the 2 clusters Ci and Cj, to measure the distance between the clusters, it is sometimes called as a nearest neighbor clustering. So moreover, if the clustering process is terminated when the distance between the nearest cluster exceeds user defined threshold, then it is called as a single linkage clustering. So if we view the data points as nodes of a graph and with edges forming a path between the nodes in a cluster, then the merging of the 2 clusters Ci and Cj corresponding to adding edge between the nearest pair of nodes in Ci and Cj. So because edges linking clusters always go between the distinct clusters, then the resulting graph will generate a tree. So an agglomerative hierarchical clustering algorithm that uses minimum distance, that is called as a minimal spanning tree algorithm. Whereas a spanning tree of a graph is a tree that connects all vertices, and minimal spanning tree is the one with the least sum of edge weights. When an algorithm uses a maximum distance, that is between the clusters Ci and Cj, to measure the distance between clusters, it is sometimes called as a farthest neighbor clustering algorithm. If the clustering process is terminated when the maximum distance between the nearest clusters exceeds user defined threshold value, it is called as a complete linkage algorithm. So by viewing the data points as the nodes of graphs with edges linking nodes, we can think of each cluster as a complete subgraph, that is with the edges connecting all the nodes in the clusters. The distance between the 2 clusters is determined by the most distinct nodes in the two clusters. So farthest neighbor algorithm tend to minimize the increase in this diameter of the distances that is in between the clusters at each iteration. So if the two clusters are rather compact and approximately equal size, then the method will produce the high quality clusters. Otherwise, the clusters produced can be meaningless. So the previous minimum and maximum measures represent the two extremes in measuring the distance between the clusters. So they tend to be very overlay sensitive to the outliers or the noise data. So use of mean or average distance is a compromise between the minimum and the maximum distances and overcomes the outlier sensitivity problem. So whereas the minimum distance, mean distance is the simplest to compute, the average distance is advantageous so that it can handle the categoric as well as a numeric data. So the computation of mean vector for categoric data can be difficult or the impossible to define. So let us just quickly understand from this example, like how the clustering using a single linkage that would be represented in the form of a dendroid, and next the clustering using the complete linkage. This example also obtained from the textbook. So this example shows that by using a single linkages, we can find the hierarchical clusters defined by the local proximity. Whereas the complete linkages tends to cluster the opting for the global closeness. So that is a major difference between this a single linkage versus a complete linkage. So thank you for watching this video.